In the dusty hills of China's Yunyang Basin, workers clearing rock for a survey noticed something unusual: oval shapes protruding from the cliff face. At first, they resembled weathered stones, but closer inspection revealed delicate ridges and patterns unmistakably belonging to fossilized eggs. Soon, paleontologists were on site, carefully brushing away sediment to uncover an astonishing scene: an entire clutch of dinosaur eggs preserved together. Laid 86 million years ago, 28 eggs in total formed the nest. Some clustered tightly, others spread in arcs, as if the mother had arranged them deliberately. For scientists, this was no ordinary find. Dinosaur eggs are fragile and often destroyed by erosion or pressure. To discover such a large group intact was akin to finding a prehistoric time capsule, capturing a moment of reproduction frozen in stone. These eggs belong to creatures whose lives ended tens of millions of years before the asteroid strike. Yet here, their most vulnerable stage before life even began was preserved. The discovery raised questions that resonate with anyone curious about life's origins. How did dinosaurs care for their young? Did they guard nests like modern birds, or leave eggs to fate? Each egg held a fragment of that story. To understand these eggs, we must travel back 86 million years to the late Cretaceous. The Yunyang Basin was then a lush floodplain, crossed by rivers and fringed with dense vegetation. The climate was humid, seasonal, and rich in plant growth. Herds of herbivorous dinosaurs, perhaps hadrosaurs or titanosaurs, roamed the lowlands. Carnivores prowled the edges, waiting for an opportunity to raid nests. Crocodile-like reptiles and turtles thrived in rivers, while early birds filled the skies. This was a world at its peak of dinosaur diversity. Asia, particularly China and Mongolia, was a hotspot of evolutionary innovation. Fossils from the Gobi Desert revealed feathered raptors, oviraptors guarding nests, and even embryos preserved inside eggs. The Yunyang eggs fit into this broader story, adding depth to the narrative of reproduction. For American audiences familiar with Hell Creek or Montana fossil beds, Asia's fossil sites act as a parallel stage, showing that dinosaurs thrived globally. Just as North America preserves the final days of dinosaurs, Asia preserves their intimate beginnings. The eggs in Yunyang remind us that long before extinction, dinosaurs were thriving, nesting, and ensuring the next generation would inherit the Earth. The excavation of the Yunyang eggs became a meticulous process. Once the initial cluster was spotted, paleontologists created plaster jackets around the fragile fossils, securing them for transport. Each egg was only a few inches across, yet inside lay intricate details: shell thickness, pore patterns, and sometimes mineralized traces of embryonic tissue. Local villagers watched as scientists uncovered row after row of eggs, marveling at the scale of the nest. 28 eggs in a single clutch suggested a massive reproductive effort. Unlike reptiles that lay only a few eggs, many dinosaurs appear to have relied on quantity, producing large clutches to maximize survival odds. The name of the discovery site, Qinglengshan Fossil Protection Area, soon entered headlines across China. What made this find even more important was the application of uranium-lead dating directly on the eggshells. For the first time, scientists could establish a precise age, around 86 million years. This level of accuracy turned a fascinating fossil into a scientific milestone for older audiences. It echoed the great fossil hunts of the 19th and 20th centuries, when each new discovery rewrote textbooks. Yet, unlike the chaotic bone wars, this excavation was careful, collaborative, and celebrated by local communities. A clutch of eggs, once hidden in rock, had become a global symbol of life's resilience. What do these eggs tell us about dinosaur biology? First, their structure. Each egg is oval, with a tough shell about 2 millimeters thick. Under magnification, the surface reveals a honeycomb of pores designed for gas exchange. These openings allowed oxygen to enter and carbon dioxide to escape while keeping the embryo safe. The arrangement of eggs in arcs suggests deliberate nesting behavior, perhaps with the mother scraping a shallow pit and laying eggs in rings. Inside, the eggs once contained yolk and developing embryos, while most biological material has long vanished. Mineralized impressions and microscopic crystals sometimes preserve ghostly outlines of vessels or embryonic tissues. The similarity to bird eggs is striking, like chickens or ostriches today. Dinosaurs invested heavily in protective shells. Yet, unlike most reptiles, many dinosaurs seem to have arranged nests communally or guarded them. Fossils of oviraptors have been found crouched over nests, wings spread as if shielding eggs. Did the Yunyang mother do the same? The eggs themselves cannot answer, but their arrangement hints at care. They were not scattered randomly, but placed with intent. Anatomy, combined with context, transforms these simple fossils into evidence of parental strategies, bridging reptiles and birds across deep time. The real breakthrough of the Yunyang eggs was not just their discovery, but the technology used to date them. Traditionally, paleontologists estimated age by dating surrounding rock layers, an indirect method prone to error. But with uranium-lead isotopic dating, scientists could analyze the eggshells themselves. Uranium slowly decays into lead at a known rate, and by measuring the ratio, researchers determined the egg's age at 86 million years. This placed them squarely in the late Cretaceous, long before the asteroid strike that ended the dinosaurs. More importantly, it proved that such techniques could refine timelines for dinosaur reproduction. Beyond dating, geochemical tests revealed minerals that hinted at the environment: calcium carbonate from the shells, silica from surrounding sediments, and trace elements showing waterlogged conditions during burial. Together, these data painted a picture of life and sudden death. Perhaps the nest was buried by a flood, entombing eggs before they could hatch. For paleontology, it marked a methodological leap forward. For the public, it meant we can now know with confidence not just how dinosaurs lived, but exactly when they laid their eggs. Each technological step makes fossils speak with greater clarity, turning stone into stories. The Yunyang clutch is not an isolated find. Asia has long been central to understanding dinosaur reproduction. In Mongolia's Gobi Desert, paleontologists unearthed entire nests of oviraptors, sometimes preserved in brooding poses, wings spread across eggs. In China's Liaoning province, delicate fossils captured embryos curled inside eggs, revealing developmental stages. The Yunyang eggs extend this tradition, showing that large clutches were widespread across Asia. Such discoveries reshaped theories about parental care. For decades, dinosaurs were depicted as cold-blooded reptiles that abandoned their young. Yet fossil nests suggest otherwise: brooding, communal nesting, and even evidence of post-hatching care link dinosaurs more closely to modern birds. Asia's role is crucial because its fossil sites preserve not only bones, but behavior. For American viewers, this echoes discoveries in North America, like the Maiasaura nests of Montana that revealed good mother lizards. Together, Asia and America tell a shared story. Dinosaurs were complex, nurturing, and socially advanced. The Yunyang clutch adds weight to the argument that many dinosaurs invested in their offspring, ensuring survival through both quantity and care. The eggs, therefore, are not just fossils. They are testimonies of family life, written in stone across continents. Imagine the late Cretaceous morning in Yunyang. The floodplain is alive with sound. In a shallow scrape of earth, a female dinosaur lowers her body, carefully depositing eggs in arcs. She nudges them into place, ensuring space for gas exchange. Her nostrils flare as she covers them lightly with vegetation, both to hide them and to regulate temperature. The air is filled with danger. Crocodile-like predators stalk the riverbanks, while raptors scan for easy meals. Yet, the mother remains, circling the nest, tail swishing in defiance. Days pass, sunlight bakes the ground, and storms roll in, pounding the soil with rain. The eggs endure it all, protected by tough shells and maternal vigilance. Young males spar nearby, but they keep their distance from the nest. At night, the female crouches low, using her body to shield the eggs from cold. For weeks, life centers on this clutch 28 fragile ovals containing the next generation. Then disaster strikes. A sudden flood surges through the floodplain, submerging the nest in mud. The eggs suffocate, their promise unfulfilled. Yet in this tragedy lies preservation. Encased in sediment, they fossilize, carrying forward the story of ancient reproduction. For modern eyes, they offer not just anatomy, but drama, survival, and loss. The Yunyang eggs are more than static fossils. With modern tools, they become dynamic sources of knowledge. CT scans allow scientists to look inside without cracking shells, sometimes revealing curled embryos or patterns of mineralization where tissue once was. Spectroscopy detects traces of proteins and pigments, suggesting how eggs might have looked in life. Some studies indicate dinosaur eggs were not uniformly white, but came in shades of blue or green, perhaps for camouflage or signaling. In the Yunyang case, geochemical analysis showed that water played a role in fossilization, filling the eggs with minerals that preserved their shape. Experimental impact tests helped determine whether eggs were buried under vegetation, left open, or partially covered. Each technique adds layers of understanding. For the public, this is like science fiction come-true machines that peer through stone, resurrecting lost details of life. For older audiences, it shows how far paleontology has come since the days of plaster casts and guesswork. The eggs, silent for millions of years, now speak with a scientific voice amplified by technology. They remind us that fossils are not just relics, but active participants in ongoing discovery. Why do dinosaur eggs capture such fascination? Part of it lies in their symbolism. Eggs represent beginnings, potential, and continuity. To see an ancient egg is to glimpse life at its most vulnerable, before it had a chance to hatch. For Mongolia and China, these discoveries strengthen cultural pride and fossil heritage, inspiring museums, exhibitions, and tourism. For the global public, they reignite childhood wonder. In the 1990s, movies like Jurassic Park placed dinosaur eggs at the center of plots, cementing their place in popular imagination. For older audiences, eggs tie nostalgia to novelty, once the stuff of storybooks. They are now real, tangible, and studied with modern precision. They also serve education. Museum displays of fossil eggs draw millions, helping children and adults alike imagine dinosaurs as living, breathing animals. For Americans, the Yunyang eggs recall discoveries closer to home, such as Maiasaura nests in Montana. Together, they create a universal connection across continents and cultures. Eggs speak a common language of life. Their importance extends beyond science. They embody resilience, hope, and curiosity, reminding us that even the smallest fossil can tell the grandest story of survival. The Yunyang clutch stands as more than a remarkable fossil. It is a reminder that the story of dinosaurs is not only about giants like Rex or Triceratops, but also about their most fragile beginnings. 28 eggs, laid in a floodplain, buried by disaster, and preserved for 86 million years, now shape our understanding of reproduction and care. Their legacy is threefold. First, they confirm that dinosaurs had complex nesting behaviors, bridging reptiles and birds. Second, they demonstrate how technology can unlock new insights from ancient material. Third, they inspire future exploration. Across China, Mongolia, and beyond, countless eggs remain buried, waiting to extend the story further back. Each discovery has the potential to redefine timelines and behaviors. For audiences worldwide, especially those who grew up with dinosaurs as both science and myth. The message is powerful. The age of discovery is far from over. Every egg is a time capsule containing not only the potential of life, but also the secrets of the past. The legacy of the Yunyang clutch is not just about what was lost, but about what we continue to learn egg by egg, story by story, across the deep history of life.